In this video, we'll explore what data parsing and transformation are, why they're crucial for observability and security, and how NXLog Platform help us manage them effectively and efficiently. What is data parsing and transformation? Data parsing and data transformation are two distinct but closely related processes in log management. To build a solid understanding, let's start by defining each of them. Data parsing is the process of analyzing raw log data and breaking it down into structured components. The goal is to convert unstructured or semi-structured logs into a consistent, readable, and queryable format. Once data are parsed and structured, the next step is data transformation. Data transformation involves modifying or enriching log data to make it more useful, secure, or consistent, especially when sending logs to downstream systems like SIEMs, log analytics platforms, or cloud logging services. While parsing extract structure, transformation focuses on normalizing data, masking sensitive values, enriching logs with external context, and converting data to a specific format. Many SIEMs and observability platforms require data in specific formats like JSON. If your sources don't produce data in the required format, NXLog Platform steps in to handle the transformation. Now let's take a quick look at how data processing works in the NXLog agent. As shown in this diagram, the flow starts from the input, where raw log data is collected, for example from files, system logs, or network sources. Next, the data go through the parse stage, where unstructured data is converted into structured fields using parsing functions. From there, the data enters the process or normalize stage. This is where we transform the data by filtering, renaming fields, or applying logic to standardize the data. Finally, the data are sent to the output, which could be a file, a remote server, a SIEM platform, or even stored and managed directly within the NXLog platform for centralized monitoring and analysis. This end-to-end flow ensures that logs are not only collected but also enriched, transformed, and delivered in a consistent and actionable format. Now let's look at a simple configuration that demonstrates how NXLog parses syslog messages from a file and transforms them into JSON format. For this use case, we'll enable the View Configuration as Text option to edit the configuration in plain text. In this example, we will collect raw syslog events using the im file module and parse them into a structured format. The parsed events are then transformed into JSON format and forwarded to a file using the om file module. Let's check the output file to confirm that the NXLog agent has collected new entries. As you can see, the NXLog agent collects events in real time. The syslog events are successfully parsed and transformed into JSON format. NXLog automatically adds 4 core fields to each event. Event receive time, which records the exact time the agent received the log. Hostname, identifying the system that generated the event. Source module name, indicating the name of the input module. And source module type, which specifies the type of module used to collect the log. In addition to these, NXLog includes other useful fields extracted directly from the log. Event time, the original timestamp from the log. Syslog facility and syslog severity, indicating the origin and severity level of the event. Process ID, source name, and message provide context about the process and the actual log content. All of this is structured and written to the specified output file in clean, readable JSON format, ready for further analysis or forwarding to external systems. Let's further transform the collected events using the XM rewrite module. This module allows us to manipulate event records by renaming fields, deleting unwanted fields, or keeping only the fields we need. It helps clean and simplify the final output. In this example, we will load the XM rewrite extension to help us transform and simplify our log events. We're using the keep directive to limit the event to just 5 key fields: event time, severity, host name, source name, and message. This ensures that only the most relevant data is retained. Next, with the rename directive, We're mapping these fields to shorter or more standard names to improve readability or align with downstream systems. Event time becomes timestamp. Host name becomes host. Source name becomes SRC short for source. Message becomes MSG short for message. Severity becomes sev. Once these rules are defined, we apply the transformation inside the input block. Let's take a look at the result of applying the XM rewrite extension module to our configuration. You can see the output is much cleaner and more focused. In the XM rewrite block, we use the keep directive to retain only 5 specific fields: event time, severity, host name, source name, and message. This helps reduce noise by removing all other unnecessary fields. We then applied the rename directive to rename each of those fields to shorter, more standardized names. Event time is renamed to timestamp, which shows when the event occurred. Severity becomes sev, indicating the severity level. Host name becomes host, representing the source system. Source name becomes SOS, the source application. And message is renamed to MSG, which is the actual log message. By doing this, each event record is simplified before it's converted to JSON and written to the output file. This kind of transformation helps keep the data clean and consistent, especially when preparing it for use in dashboards or external log analysis systems. Thank you for watching.